At any point of time, you can stop me and tell whether something more to be added or something more to be reduced. Okay, so the first phase in the next 10 to 20 minutes, we'll try to discuss why industry has moved towards deep learning. Is it advantageous over machine learning, or should both be used in parallel? Okay, so in a different perspective, I thought it would be on a different perspective, hope so. And can I have some interaction for 5 to 10 minutes so that I can also have a feel of being with you? Okay, so how do we perceive this diagram? How does it look like? Can I have answers from any of the participants, please? What do you feel by looking at this picture? Yes, anybody? Ma'am, is it that they can't mute themselves?
No,
Unmute themselves?
no, ma'am. No, no.
Okay, fine. Somebody has given the solution. Yeah. Yeah. So, chemistry class teacher teaching solve and solute maybe. Yeah, thank you, Kyle Vidi madam. Exactly, that is also one kind of interpretation. What kind of environment is it? How do you feel? What kind of environment does it look like? Is it how are we talking now, or what kind of environment?
Classroom
Somebody gave
teaching.
Yeah, thank you. So it is actually a traditional classroom teaching which we all have gone into till the March mid. Okay, so we all have enjoyed this kind of teaching. So the word enjoyment matters a lot when we think of the previous sessions and now. Okay, so what do we do actually in teaching? Okay, I hope most of you are all professor, and if not also might be a professor at the family level also. So what do we do when we go and interact with the students? The teacher, right? 1 minute. Yeah, the teacher is able to understand so many different skill sets of the students. Okay, be it the listening skill of how much he is listening. Okay, so on a particular date, whether he is attentive or he's attractive, or whether his listening skill got over, how much is he able to understand on one period of all that we are able to acquire. Similarly, the areas of interest of a particular student. Okay, so if I'm teaching one mathematical problem, the student might be more interested when on the next day when I'm trying to teach more theoretical concept. Okay, the student may feel bored and he may be lying down, or his mind may be wavering somewhere. Okay, so by eye to eye contact we are able to understand what are their interest areas, then their understanding level. It's a known fact that even at our home the kids won't be on the same understanding level. It will be every human being will have their own understanding. So somebody might be very good in practical, somebody may be very good in remembering. So many different stages are there and their understanding levels are also there. That also, when we go discuss with them in person, trying to have an eye-to-eye contact, talking to them in person, all we can understand. Then very important thing is the learning styles. Okay. Today it's of more important because this generation, which we call as Gen Z, is not actually of same type. We have auditory learners, we have visual learner. Somebody is using only textbook even now. That is not any wrong in any way. Everybody has a different interest, right? See, I am good at only visual learning. When I'm looking at a visual interface, I feel happy and I feel enthusiastic. Okay, and I'm trying to deliver, or I'm trying to get more information from that. Okay, those concerns the learning styles. So as a teacher, we are trying to, nowadays it's not like earlier. Even in government schools, if you look at the way they are creating animations, the way they are trying to solve the problem is very innovative, and we can't feel the difference between any kind of teaching nowadays. So as and when different set of materials are given to the students, all these things, when we are interacting with them in person in a traditional classroom environment, we can able to understand and acquire. Okay, so all the details. With that, you can you are conducting exams to the student. Okay, so you are teaching them, you are conducting exams. What is our real motto when a student enters to us? Okay, our motto is to make him achieve success. Success is not only on the base scale, we want them to achieve success on a better scale, okay, to get graduated. That's what is our motto. Sometimes it may happen on a well disciplined perspective, sometimes it may not happen, that's fine, but our motto is that, okay. So it is an actual fact that not in the initial stage itself everyone is able to achieve that goal, okay. The student might be in a very lower scale, so you teach them, you are conducting an exam, that is you're evaluating them on a different scale, be it an online exam using multi-objective questions or any descriptive question. You do any kind of evaluation, okay. So you are conducting an exam, you found the student to be on a very lower scale, okay. So then what the teacher will do, they will try to think about the student, they'll try to understand, okay, how, in what perspective is he good. If he is good as he is an auditory learner, we'll be trying to enforce them with a lot of such materials, increasing the weightage on that proportion, okay. And we'll be trying to plan on how this student can be taken up in their life on a next day, and will act accordingly, okay. Think, plan, act. So everyone is into accreditations, this is what is the actual plan, okay. So you have to think about the slow learners, plan accordingly, act accordingly. So when you do so, automatically the student moves on to the next grade, okay. Again, the performance will not be enough for us, okay. Our aim is something different, but he is only at this level. So again, we do the same activity, now trying to differ on a different scale. We interact with the person, we try to understand their pros and cons, and then we'll try to arrive at a proper weightage for the materials that you're serving, okay. So by repeating the same, okay, so he is able to achieve on a better scale. Now with he is on a one stage more than that, finally he is able to achieve the success, right? So what do we do in the classroom actually, which traditional classroom environment? So we'll try to identify these things, okay. So what these things are, they are their actual, yeah, 1 minute, sorry. Yeah, so we'll try to arrive understand what are the differing capabilities, okay. These capabilities differ from person to person. You take student 1, what are their different capabilities, we try to note it down, okay. You take student 2, student 3, and so on. We know what is the output of each and every student, right? And we'll try to give some improvement strategies. These are the strategies that we are trying to give for every student. Finally, when you club these two, we are able to arrive at a success story, okay. So they are in this stage. Finally, as you increase, they are moving to a final stage. So that's what is happening on a traditional classroom environment. But what happens now, okay, so from March 24th or the third week onwards, we are all held up at home, okay, asking us to stay safe at home itself. But the learning is happening, okay. You and me are trying to take classes to all the students over here. The entire world is getting adapted to a laptop of this kind, from where we'll be talking separately. I don't know any of you who are talking in the session, what is the level of knowledge you acquired, what is that people have taught till date, okay. So many different things are there trying to that has to be understood, but I haven't understood anything. I have prepared my lecture in my own way. I'm just distributing it to all of you, right? So that's what is happening. As a teacher, see this, when I become a mentor, I become a teacher for the session. Am I understanding what is the skill set you provide, you have? No, okay. Whether your interest areas, are you okay with my teaching, am I looking at now? No, okay. But you assume the same session in a classroom environment. I will look at your eyes. When you feel bored, automatically I can change my strategic plan to something else, okay. Now nothing is possible. So we are not able to understand what your learning style is, what kind of material would be beneficial of you, okay. No interactions, nothing, no eyesight, no social behavior, social interaction between the people. But what is expected out of this virtual classroom is again a success, okay. When I ask you for my feedback, normally any teacher want a good feedback, in the sense of what is that feedback. It is not what we are writing on the paper or on the digital thing. It is what is the performance of the student that we say is the achievement. So this achievement is what is actually expected from the student community, be it in your traditional classroom or your virtual classroom. Not everyone is able to achieve 100%, right? So if almost you have crossed some around 9+2, 11 speakers. Okay, if you are asked to rate, you cannot give equal weightage to all the 11 speakers, but everyone might be different in their own perspective. Okay, so you have a rating scale like this. Somebody might be on this point, somebody might be on this point, somebody might be on this point. That is individual's perception. But what is, if at any point of time we need success. Okay, but do I bothering, well, that is whether I am bothering about how this success is coming on? No. Okay, I am not bothering on how the success is being met. Rather, I am that is worried only on the success. Success is nothing but the concept that you all have acquired what I am trying to say by means of these factors. Right. So whatever be it, okay, your traditional classroom environment or your virtual classroom environment, okay, there are a lot of these features or the skills that the student should acquire on in their particular learning. Okay, so in a traditional environment, we say it is a teacher-centric environment where the teacher tries to understand what are the characteristics that are contributing to the success of a particular person, right? So if a person gets S grade, the student or the teacher knows what are the differing characteristics or the features that makes the student to reach that level. If a student got F grade, then the teacher can able to understand what are the different characteristics that makes the student to reach that failure grade. Okay, accordingly the plan of action can be set. But what is happening in virtual environment? It's learner centric, right? Nowadays I'm looking at my son for say if they have 6 hours of session per day. Okay, so 4 hours he'll be sitting and 2 hours he is roaming around. If we ask, they are telling like it is boring. They are teaching what they have taught yesterday. It is similar to the last session, so I can better go for a very different visual studio. So many reasons are there for the people. Okay, even now we cannot restrict any of the people to sit and talk only, listen only to my audio or video. So that's where it is becoming learner centric, where the learners alone are deciding who has to be, what should be the characteristics that they should acquire. Okay, if they feel like the characteristic are not good, if you feel like I'm getting more into of basic, and if you're good at basic, you can leave the session. That's up to you. Okay, no one is there to control you. So that's what becomes learner centric. So whatever be it your teacher centric process or learner centric process, what is happening is nothing but your learning. Okay, so only this learning, there it is more focused by the teacher, here it is more focused by the individual, which is the learner. Okay, so here this entire process of traditional classroom or virtual classroom, I try to relate to the topic of today. So the learning which we call it as teacher centric, we can relate to machine learning. So machine learning, what does it do? Okay, the teacher is nothing but a model. The whatever qualities that you want the student should have, or that you think the student should have, become the attributes of your data set. Okay, so for every student you are trying to collect the data set. Who is deciding the feature? It is only the teacher. Okay, so the developer community or the data scientists try to say that these are the features that contributes to this problem domain, and you try to collect the attributes of this. Okay, if they feel that this is good, it will be there. If they feel that, so the model, any model if you take, it will try to go acquire the capabilities, okay, acquire the data set. It will work only on the data set that you are providing. It will come with an output, okay, not more than that. But when it becomes to learner centric, you can better map it to deep learning, wherein all the materials are given to you, right? Your inputs are given to you. It is about the model to pick up the features that you want. It is about you people who can pick up the data that is flooded to you. Okay, you will be given with the PPT, you will be given with the recording, you will be given with the assignment problem, so many other things. Okay, it's up to you to pick up which feature is important for you and to progress. Okay, so it's completely a black box. I'm not going to find out which material are you going to learn. My only intention is to receive a good result from you. Okay, so that is about the deep learning. And this deep learning has gone into such an extent. Okay, so yesterday in the morning session in the Swagatam Das sir's class, you could have seen the evolution. Okay, we also have the one session or one phase of that. See, the evolution has gone into an extent that We don't need to bother about anything rather than the input alone, which we need to feed. Okay, you give the input to the machine, let it try to find out whatever details that it could able to find out. Okay, so it is like you are throwing a person onto ST, okay, and leaving them for a month, asking them what they learned from a city. Okay, so we are not restricting the person to learn this, that, or we are not teaching them how the city is looking like, who's the, see, let them learn, let them find, let them explore, let them drop out something, some information, let them come out with a productive information. Whether that information is useful for us or not, that alone let us decide. Okay, so this I think this figure can give you lot many inputs on that. So the only the information the machine is exposed to the input. Okay, so it is going to give you only the output. All that what is happening at the assumed to be a black box. So many internetworking happens, which is creating a lot of computing power requirement. Okay, but so what you can do when you move on to use deep learning is you can leave everything to the hands of machine and you can stay relaxed. Okay, as long as you are only an user or a teacher. When you want to move yourself to a research area, it's something different. Okay, so to relate all these things of context of what we have seen till now, learning has got so many different attributes. Okay, one is the materials that we are going to supply, be it your quizzes or multi-objective questions or descriptive questions or the videos or the PPTs or the textual contents or the soft copy books or whatever it is, all that we call it as materials. And there should be an understanding on the learner style, right? And then sequel, that is periodically we should go for a performance analysis. Otherwise, nothing will be of use. Okay, you think of teaching without examination, what will happen to the community? Okay, so we will be sorry, everyone will be into a different side. No one will have interest. So in order to periodically assess the performance, we need to go for performance analysis, which we call as result analysis. And based on the result, we should lay out our improvement strategies. Okay, so how do we improve? When the result is not appreciable, your HOD may ask you to improve. What are the improvement strategies that we lay out? And then what are the innovations in teaching that you can bring up? It's not always that only the same flow we need to follow. Okay, so it's the fact that you need to find out lot many new innovations to keep the audience interesting. Okay, it might be the same information that you are trying to deliver amidst so many people, but you should have your own innovation. That innovation can make you distinct from other people. Okay, and finally, how to reduce the failure. Okay, whatever you do, whatever material you supply, how much ever you understand, how much ever analysis and improvement and innovations you do, finally there are cases in which the student will fail. What are you going to do with those failures? Okay, so that's the next context that we need to understand. Okay, hope this context is clear even from the professor or any perspective. Okay, so with this, when I try to map the same scenario with machine learning. Okay, so what are the materials? It is nothing but the inputs that I'm going to supply. Okay, so these inputs are nothing but the materials. Then what are the learner style that we have characteristic? So here the characteristic to be identified by the data scientist. You are trying to have an Excel sheet. Okay, the attributes needs to be identified by the data scientist. Then how do you assess the model or how do you assess the performance? It is by using performance metrics. So depending on so many, you on the previous sessions, you might have got lot many information on this. I don't want to go in deep. Metrics vary depending on the domain of usage. Okay, so if it is regression, there is a different metric. If it is classification, it's different, and it vary depends on the domain and the area of interest that you use. With that, you can go for improvement strategies. In what way can you improve? Can you change the input? Of course, it's not, right? 1 minute, somebody has given a chat. Yeah. Okay, so how do we go for improvement strategies? Okay, so what is the improvement strategy? You can't do anything on the input, that is static. Okay, it's a static data that is delivered by somebody else or your client. So where can you improve? It is where on the hyperparameters. Okay, those are the improvement strategies. Then what are the innovations that you can do? Innovations are nothing but model changing, or model, that is do some analysis on the constructed model. If necessary, try to change the model. See, when I check, I could see 80% linearity on my data, and I have went for logistic regression. Then when more data gets added on, I could see different, that is what to say, some more reduction in the linearity, and hence I'm extending it to SVM. That's model analysis. Okay, that's where we end up with innovations in teaching. I feel like this kind of teaching is good. I'm moving ahead. When I feel like there is a slowdown because of some reason or other, I have to change my style. Finally, what do we on the failures? Okay, when somebody got failed, what to do? Okay, what is failure here in machine learning? When you are not able to predict, okay, of what is actually expected, we say it is a failure. In which case, we go for regularization concept, and this regularization is what Sir was talking about yesterday in a deeper scale. Same when I try to map it to deep learning, okay. So what will happen? Inputs remain same. You don't need to bother about the inputs. Then this is the only difference. Okay, so earlier in machine learning, the features will be given by the data scientist. Here this will be identified by the model you choose. Okay, so leave the inputs to the system, let it get trained, and finally end up with the model from where you can acquire lot many features. Okay, rest of all things remain same. You have performance metrics, you have hyperparameters which you can change, then you have model analysis. Okay, so you can change one model for another if in case of necessity, and then here also you have regularization technique that you need to adapt on. Okay, hope the context is clear till now. Okay, and then we'll move on for the second phase, the evolution and platform. Any questions till now?
Madam, I have got one query.
Yes, ma'am.
Actually, when we are feeding the feature, like it is a PPT or it is the material supplied, the values are what actually given to the machine. Machine needs some value, like it is a 30% of PPT, 20% of this materials or video lecture, like this way. I am not getting the clear idea how that input is fed to the features. Values are given to the machine learning.
No, ma'am. Actually, what I mean by material is something. It's for an example, right? See, you might have prepared a PPT, you might have prepared an audio or video or anything. All that becomes the feature attributes. I'm saying. Let's say if a student is S1 is having you, if you are setting some features, you tell me some features that you think are attributes of student. Let's say if I want to fill whether he is an auditory listener, okay, or visual listener, or textual listener, what is his interest, what level of interest is there for quizzes. Okay, when you are supplying auditory information to that, the student has to be given more weightage, that's all. Okay, so here this auditory learner you'll be given 1 because the student is interested on the audio rather than text or video. And if he is good at attending the quizzes, see, you are posting quiz on Moodle, let's say, in another 5 minutes, if he is completing the quiz, you may assume that he is eager to do the quizzes. Okay, in which time you can give a scale of 5. This is what we are trying to arrive at. Okay, I mean these feature sets to be the materials, not the actual materials. Okay, you can prepare in such a way.
Oh, okay, madam.
Okay. Okay. Any other doubts? Yes, ma'am.
Another is that which feature is more responsible? Like on the heat map, we can conclude that okay, this was the feature that is more related for learning, like this way, na?
Yeah. So, ma'am, actually, since you and me have understood this concept, we can able to understand which parameter is more important. Let's say you have 15 parameters, features. Okay. So, since this domain is very, what to say, simple, and you and me can able to understand, we are able to say that the learning has to be given weightage. Okay. The examination has to be given this much of weightage likewise. But in general case, machine can't do that weightage properly. Okay, how much is the weightage given to this parameter, this parameter, this parameter? The machine can't do. So that's why we go for random weightage allotment, and finally finding out how much. That is the only requirement that people have to fix. Okay, everywhere when you start deep learning from perceptron onwards. So what do we do normally? We'll come at that, ma'am. I have that in my process.
Okay, madam. Another thing is data set is anywhere available to do the such implementation. or we need to generate the data sets?
In general, are you asking?
In general, madam, just a dummy.
By the end, at last I will show where and from where and all you can download the data sets, ma'am.
Okay, madam.
Public data sets and all I'll show you.
Okay. Thank you, madam.
Thank you. So moving on to the evolution and the different platforms, okay, in which you can use. So this evolution happens from machine learning. There is a concept called perceptron. Okay, so perceptron is the basic model of all the neural networks that we do have. From perceptron, artificial neural networks have got evolved. But if you look at more, these two things are 99% one and the same. That 1% everyone can explain in their own terms. So they are from there, while adapting the execution for most of image data sets, they have moved on for convolution neural network. So, and there is a research extension in each and every network also. ANN, it could be combined with so many other networks and it is evolving. CNN, it is also evolving, so many other things. So, and finally, convolution neural network, we don't have a memory component. So what has happened in the last stage, we are not able to understand. So in order to have that with the memory component, that is blockwise, if you want to look at, we went for recurrent neural networks or long short-term memory, LSTM we used to say. It is more or less like trying to remember what is your previous state and trying to compute the output based on that. And with the evolution of CNN and RNN, people have come for XNet. Okay, yesterday somebody was asking in the morning session, I saw. So ImageNet, XNet, I refer to ImageNet. Okay, ResNet, AlexNet. So many different architecture. Google has its own Google Net. Okay, so many different network architecture. What they do is, so since instead of trying to train a neural network model from the base level, trying to give all inputs, these XNet architectures are already trained. Okay, ImageNet is trained with more than 2 lakh, 3 lakh images, which they have collected all over the world. You give any image to that, automatically it can tell you. Okay, but when we try to develop a system, what we do, we'll try to look at only on the domain. When I'm trying to concentrate to segregate the speakers, I'll concentrate only on the figures of speaker. But rather, it's an open database that people can use. It's a massive data structure. So they already have trained and the parameters are given as output. From that stage onwards, you can take in and you can move ahead. Similar to that, you have ResNet, residual nets. Okay, so these are all different architectures which people have worked and left us. So we don't need to bother too much about how it has been evolved. Rather, an induction towards how it could be used on our projects might be of use. Okay. And for now and then, yesterday there was a great discussion on GAN, whether to use it, but we don't know whether it will be used for a good cause on a later date or not. So GAN is what is in talk now. So this is about the different evolution of how the deep learning has been evolved till this time. So why it has been evolved? That's the next question. Okay, I have made this presentation in a very basic level, understanding that it's a mixed group of professor community. So why deep learning has gone? Why not simple linear programming technique or non-linear programming like your SVM or that is a linear regression or logistic regression alone can do? Okay, it started with this example. Okay, wherever you go for multi-layer perceptron, you'll be given with this example of XOR gate. Okay, let us try to understand in deep of how it has evolved. Now that the XOR gate operation we know, when your inputs are same, it is 0 and 0 or 1 and 1, your output will be 0. And when your inputs are different, you will have a 1 as the output. Now what to do when the representation is like this? Here you can see here. So this red dots indicate the points. Okay, so referring to the inputs of x1 and x2. So when it is 0, 0, we'll have 0 as the output. When it is 1, 1, it will have 0 as the output. Anywhere in between, it is the 1. So when we try to draw the decision boundaries, it goes like this. Okay, so this is 0. Above it is also 0. In between, we have 1 as the output. Okay, how do you make it possible using single layer perceptron? In single layer perceptron, actually, what is perceptron? So let me take a minute to explain in an easier sense. You give the input, okay, x1, x2, nothing but the input. So what is the input? 0, 0. Do some computation. I don't need to bother about this computation. I want 0 as my input. Okay. Suppose if it is OR gate, simple OR gate, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. So what I do, when both my inputs are 0, I want 0 as my output. When 0 and 1 is my input, I want 1 as my output. That's all. Okay. This is the configuration. So what should I do here? I need to have some functionality written over here to arrive at this output. Okay, that function is what we call as the function. That is here what we do know, x1, okay, so is the input. I'll try to assign how much is the weightage I want to give to this parameter. Okay, I look at here when I want the 1 as my output. Okay, so when both the that is what to say, inputs are 1, I may think like x1 has the biggest that is more weight towards contributing to our output. Likewise, I may think, or the system may think. That's what we feel as weightage. So W1, X1. So I'm giving a weight to this parameter into that weight, plus similarly for the next W2, X2. Okay. So plus bias. So what is bias? In my understanding, in simple terms, what I say is it is the overall difference in the system. Okay, there may be lot many technical explanations over it, but in general, if you take, let's say, if I am giving marks for all my students, okay, and finally, if I turn back, I could see only 95 as my highest mark. Okay, and if I want to make 100 as my highest mark, what should I do? I make +5 to all my students. In which case, +5 is my bias. Okay, that is what is an addition which I have given. So if you are including some common noise over the system, then we say it as a bias. So every system will have a bias. So no system can have zero bias unless it is an ideal system. Otherwise, it will have a simple bias. That bias is what needs to be added at every computation. So finally, when you equate this, it should give you proper output. That is what is single layer perceptron. So you are just giving the inputs you are trying to compute. But can you compute like this here? It is not possible because this is your input. You have 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. Okay. So, but when you go in deeper about the arithmetic operations that can give you the result, you can check here. Okay, so this is the equation that is giving you the output of that. Okay, y is equal to x1 plus x2 multiplied by x1 bar plus x2 bar is what is the equation that will give you the output for this. Okay, so what you have to understand here is when the inputs are given, raw inputs are given before computing y. Okay, how can you compute this y? You have to first compute x1 plus x2. Then you have to compute x1 bar plus x2 bar. By using that only, see, it's not directly coming from the output. This is stage 1, giving raw input. Okay, in stage 2, you have to take these raw input as input, compute these two. Only this is going to give you the output. So is one stage enough? It's not actually. That's why we go for multi-layer perceptron. Okay, so only one step using simple operations is not always enough to arrive at output in most of the cases because the operations may be very complex. So in which case, what to do? You have to get the input. You have to compute sub-functions. Okay, sub-function is what we have shown you already. X1 plus X2 is one sub-function. X1 bar plus X2 bar is another sub-function likewise. Then you process the result of sub-function to get the output. That's where we end up with this kind of modeling. Okay, so what is actually happening is you are passing raw data as the input. It is these sub-functions are getting computed in the hidden layer. We are not bothering about how is it computed. We bother only about the output. Okay, the final layer is going to give you the output. Okay, so this is the structure you can see here, and this is what is called as your multi-layer perceptron, and this layer is what is your input. When you have input, so in XOR gate, how many inputs will be there? It is X1 and X2 alone. Okay, we'll be trying to assign weights to each and every. What is this weight? That is nothing but the weighting criterion. That is the impact of a particular attribute over the output. That's all, very simple. Okay, for example, in simple terms, when I have a student admitted to our first year class, okay, when I want to predict how much will be the grade that he will get by the end of this semester 1. Okay, given so many different details like the state from which he come in. Okay, so I'll write the state which he come in, from where he come in. Okay, his 12th marks, his 10th plus 2 10th marks. Okay, whether he is in English medium or Tamil medium. Okay, and father's name, father's mobile number, mother name. Likewise, so many details are there to me about a particular student. My duty is to find what kind of grading he will get in a first semester result. Okay, so what do you think? Which parameter may add more value to the output? My output is the grade. Okay, suppose a student will get yes, grade A, grade B, grade likewise. Can I have one or two answer? Which of these features may contribute more towards yes, the grading?
His marks, previous marks.
Previous marks, there are 2 marks, plus 2 marks and 10th marks. Whether both will contribute in the same manner or will there be any difference?
I feel 12th marks because
Yeah,
it is
12
more
marks, right? Because it is more recent, right? So this is the performance of a student in a more recent time. So what will happen? The weightage given to this will be very more. Okay. So compared to this, the weightage given to 10th marks will be less. So W2 will be less than W1. And then English or Tamil medium. Okay. So whether if he is in English medium, he don't find very much difficulty in moving. But if he is in any other state medium, no, automatically there will be a difficulty. So there it may also give an impact. Okay, so where W3 is less than W2, less than W1. Other things like state, father number, father number, name and father mobile number are not going to give any contribution towards the output. What about state? Sometimes it may contribute, so that you can give a very meager weightage. Okay, altogether basically the total will come to 1. Okay, so these are how the weights are getting understood. But how do the machine know how much weight needs to be given? Okay, no one knows. That's why we say the weight needs to be assigned at random. Okay, so you start with random weights. When a student gets admitted, we don't know how much training we need to give them. Initially, we start with our own thought. Okay, when we see the result, we turn back and then we'll change our own style. Similar to that, here we add a random weight to that. Using that random weight, using the activation, taking the summation, add with the bias of the system. Okay, so finally, this is what is the hidden layer. Why to have a hidden layer now? Just we saw, when you want to have sub functions computed, you need to have a hidden layer. Okay, so the hidden layer, so this one, the H1 will compute x1 plus x2, H2 will compute x1 bar plus x2 bar. Okay, so once this is computed, again this will have their own weights to arrive at the output. Okay, finally this output is what you want. So basically it will give you some values between 0 to 1 as an output. So we will break like when the value is less than 0.5 will give 0, or greater than 0.5 it is 1 on the binary class classification. So this section is very vast. How are you going to predict? So this is what is your output layer. So this is the basic structure of any neural network. If you say, the only thing varies is the type of hidden layer, number of hidden layers. How do you find what? How are you initializing? Are you going to have in the input hidden layer? Because here we know what is the concept. It is XOR gate. We know that only 2 sub-functions are there. We are giving 2 nodes. Okay, but in general, if you are giving dog cat feature over here, how do you know how many features are there? We vary. We go for a trial and error method. Find out how is it going to affect on the output. Okay, that's how it is going on. And I will stop with this without moving on further more about CNN and all, because you already have very good introduction. So this is about artificial neural network, the same of what we have seen in the multi-layer perceptron. So, but what happens here, all your inputs are given. It is taken forward to the next layer, that is feed forward networks. Okay, you are feeding the output of one layer forward to the next layer as the input. Every layer will have their own weights and the bias. Okay, so that is what is that. And finally, on reaching the output layer, you look at the output. Okay, when it is convincing, fine, we can stop. When it is not convincing, what do? We'll try to backtrack, correcting all the errors, okay, stage by stage, because you cannot jump from the output layer to the input layer if you have 10 layers in between. So what do? From the last layer, you will move on to last but one layer, correcting the output, and then you move on till you reach your input layer. This process is what we call as back propagation. Okay, so this feed forward and back propagation are the very important and the only two important techniques that play around in all your deep neural networks. Why deep neural networks is taking too many computations and time? It is because of this back propagation. Only when you reach your output, let's say you have a new net model, okay, neural network model having 50 hidden layers. Okay, so after computing all the things, okay, only when you reach your final output, you can come to know whether your output is correct or wrong. If it is wrong, you have to go back till all your 50 layers, trying to do all the computations, and then again you have to turn back. That's why it is taking too much of time. Okay, so gradient descent I have, if time permits, I will show you in a simpler way later on. So coming to the different platforms that are available for execution. So earlier we have piano platform, even now it is an interesting platform, but the industry has moved towards TensorFlow. Okay, so TensorFlow is actually a open source platform that you can use very well and it is providing long-term support for all the deep learning networks as well, with the provision to have your own additions over there. Suppose if you want to make some changes on any hyperparameters or anything, it gives you that provision. Then you have Keras again, a similar kind of framework that also is a comfortable framework you can use. You have PyTorch, okay, which is currently open source, earlier not like so. PyTorch has one advantage, I should say. Okay, so here everyone is talking about back propagation. So when you want to back propagate, normally in databases, when you work on transactions, okay, we should remember the concept of rollback. So what this rollback will do, it will try to take you back to the previous state. Okay, so it's always important because so unknowingly we may have branched on to the next state. You think of a machine without control is it? What do? The entire life of a software engineer will get stuck. Okay, so the most useful key that we could see is only the control Z key. So that control Z key is provided very easily in PyTorch. So if you use PyTorch environment, the entire tensors can be used as such. So tensor means you could visualize it as one matrix. One matrix could be assumed as one tensor, like one data frame in pandas. In pandas, you could have studied about data frames. Similar to that, in tensor, we call it as PyTorch, we call it as tensor. That is the advantage. Then Cafe. So these are the different frameworks which you can use. You can select, you're free to select your own framework. And based on what kind of processor that you have. Basically, all our laptops will have this CPU. But the number of computations as and when it grows more, particularly when you are talking about graphs, images. Okay, so CPU will not support, in which case you have to go for graphical processor unit. So how do you have your graphical processor unit? If you don't have in your laptop, better you can go for Google Colab. Okay, so if someone is not able to understand, I'll tell you at the last. There you have the provision to choose your infrastructure. They are giving at free of cost. So for GPU, CPU, and even TPU, tensor processing unit. Okay, tensors will be processed at a time. We are not moving to that level. Still, people are using till CPU. And one more important word that people should understand is about the CUDA, which is a parallel computing provided by NVIDIA. So, and this Keras and TensorFlow are supporting a lot on the, even PyTorch is giving a good support for CUDA. Okay, so that is parallel computing on provided by NVIDIA. So, in all its GPUs, that is also there available in your Google Colab. So that is about the different evolution and the platforms that we do have. And coming to the topic of interest today, optimization. So I haven't gone deep into CNN, RNN and all because enough of that would have been discussed in the earlier session. So since it is going to near lunch, okay, so we'll move on. So about the third phase of discussion, which is optimization. So this is what we'll be discussing at. What is optimization, why, and can we relate optimization with deep learning? Okay, if so, why should we relate? That's the question. Okay, so any other questions till now, or shall we move ahead? Yes, shall we proceed?
Yes, ma'am. Yes, ma'am.
Yeah, thank you. Yeah. So what is optimization? So different perspectives, different what to say definitions might be there, but among so many different perspective. One on the engineering perspective is process of searching for combination of parameters that will result in best outcome according to a set of criteria. Okay. So it's more simpler like today the entire world is moving towards design thinking, right? So how do we define design thinking? So it's not about the client coming and giving a problem to a company or an entrepreneur, to a development company as of now. The entire industry is moving towards design thinking. Even in companies, they have a very big whiteboard, or we went to one company wherein they have the entire glass made of only that is capable of writing anything. So meaning that any person who at whatever time he is getting new idea, he has free and go right on the board, so that it can prick somebody else's mind, and it could become a new product in the market. Why? Because the industry has almost standardized now. If you look at any kind of product, let's say if it is that is a diabetic recommender, or what to say, your that the morning people will use now, like how many kind of counts how many number of walks you are moving on, anything you have. N number, thousands of apps are coming on day to day. Okay, so when you wake up now, tomorrow you have 100 more apps on the Play Store or App Store, anything. Okay, so what the industry expects from the student community and from us is the design thinking. So I have to prick lot many problem domain, arrive at a set of problems that are feasible for implementation. So that is what is design thinking. You are searching on the problem domain, you are coming up with n number of problems which you think can be feasible. You have to do a feasibility study. Once this feasibility study is done, okay, for every problem you can arrive at one problem. So you look at all the problems, you think of which one you can do. Not everything is doable. Finally you pick up one problem. Now do you think the solutions will be available readily for the problem or not? Yes, it is not like earlier days where we have to write solutions of our own. Anything, if you search in the internet with the right perspective, automatically you will get solutions. Solution 1, solution 2, solution 3, solution 4. So it is that solution domain is vast rather than the problem domain. Okay, we are not able to confine at a particular problem. Okay, so this is about the design thinking. Okay, so with this perspective of design thinking, if you look at this optimization, you can see where and all we are actually using in an engineering perspective. It's not only on the mathematical perspective, it's on the engineering perspective where and all we actually apply optimization. So we are looking for combination of parameters that will result in the best outcome. Okay, so this solution we look at and we'll try to pick up a particular solution that can give you a best output based on the criteria that you give. Okay, so how do you do? Okay, that's where we call it as the feasibility study. So this feasibility study depends on the criteria that you set. Okay, so suppose I have a very simple example here. This example we would have visualized in so many places. Before you have some around 7 doors. Okay, I'm telling you that there is a treasure behind any one door, and you are free to move. Okay, and you can pick up the treasure of wherever it is. Okay, so what do? At times you'll get confused of which door needs to be open, and always if my mind is telling that I have to open to my left and open the first door, the other immediately the other person sitting in my mind will say that no, go fast, somebody else will come and catch you, go to the right door and take. Somebody else will, so all that will happen in our mind. Okay, so we'll be in a dilemma of what to do. Okay, whether to move towards the left or to middle or to the right or what. Okay, so this is what kind of what do you do? Okay, so now when you are given a constraint that you have to use only 2 doors, and you have to, wherever you are standing, from there you have to use only the doors towards your right. Okay, now that your problem domain gets shrunk. Okay, so whether looking or going to all the doors are feasible. Okay, so the problem is you are given with multiple solutions. Okay, the solutions before you are many. You are about to find an optimized solution based on the criteria. The concept here needs to understand is, this is the problem domain. Okay, this is the problem domain. So what is the problem domain? It is nothing but the doors which you want to open. The same becomes your constraints also. Okay, so in constraints also we will use the same variables. So that is what is we call as the optimization problem. So optimization problem mostly in engineering industry. So in engineering optimization, we say it is mostly found in the mechanical industry. When it is marketing, we say that we have to maximize the profit. Okay, when it is manufacturing, we say that we have to minimize the errors of the products. Okay, in whatever case, what needs to be understood is, what is optimization? Given a problem, you should be able to arrive at a maximization or a minimization problem. So the same variables what you are using here has to come as the constraints also. Okay, so once having done this, this is the kind of optimization problem that you will use. A very simple example is minimize x subject to f of x. Similarly, you can have maximize x subject to f of x. So what is in relation to this previous diagram? The minimize the number of door movement. Okay, you have to use only 2 doors. So what is the problem here? Minimize f of x, what the number of door openings might be the and what is the second thing? You have to acquire the treasure. What is the condition? What are the subject to? What are the constraints you are giving? This equal to, if you put, it is called as equality constraint. Less than, if you put, it is called as inequality constraint. Okay. For your problem domain, you have to write this. Don't think these are very common. So it's all given in the perspective. In my case, I have written differently using adjacency matrix. Okay, so this constraints and the function f of x has to be written according to our problem domain. If you are able to arrive at this, that's all, our work gets over. Okay, so why are we doing this optimization? So to achieve the best design related to a set of prioritized criteria or constraints, you are given with the constraints. Apply that constraint, arrive at the best design. By means of that, what are you trying to achieve? The cost gets reduced. Cost for development gets reduced. It will increase the reliability, because optimization is used only when you are not able to give an accurate result. Okay, when you are moving towards machine learning, deep learning, or optimization. So in which case, if you want to increase your reliability, yes, of course, you have to find an optimized solution. Then by means of that, you can increase productivity and to increase your efficiency. Now, what are the different optimization techniques that are available? Okay, so not in detail. So just an overview. On linear scale, we have simplex, combinatorial, and quantum. On non-linear, this is not an exhaustive list, just for example. On non-linear, we have Newton's method, gradient descent, ellipsoid, stochastic approximation. These two, if you see, there is a difference between these two and the heuristic technique. Meta-heuristic people normally say. There are a lot of algorithms here: genetic algorithm, ant colony, particle swarm, firefly, anything and everything, memetic algorithm, and so many things. But what is the basic difference between these two categories and here is that when we say these kind of techniques, even after any number of iterations you go, be it 3 or 5 or 30, finally there is a possibility to end up with a solution. Solution is given, or you can ascertain the existence of a solution when you are using these methods. But coming to meta-heuristic, it is not like so. Anywhere, if you want to stop, you can stop. Okay, when I feel like this kind of answer is enough for me, I can stop. So you cannot expect a solution to be given by the algorithm. Rather, it's the duty of us to decide whether to stop the algorithm and take it back. How do I stop? By either by setting a threshold. Okay, let's say if my fitness function falls into this, okay, I stop and I accept that. Or else you complete 100 iterations and come to an end. Okay, so but simplex or Newton's method doesn't look like so. It will automatically converge to a solution. But this meta-heuristic techniques will never converge to a solution, rather converge to an optimized answer, which we can take it as a solution. So that is the more important understanding about this. And coming to genetic algorithm, which is the talk for the session. So it is a meta-heuristic technique inspired by process of natural selection. See, how do we evolve as a generation? So based on that, we have genetic algorithm. This requires genetic representation of solution domain. Yes, solution domain is important. It's very important to understand this fact. So we are working only on the solution domain, and the fitness function to evaluate the solution domain. How do you, when I'm giving you 10 solutions, okay, how do you say that one is good, second is okay, like third is bad? What is the fitness function that you are going to use in order to evaluate the solution domain? With that, it goes through these steps. We'll have a population. Okay, so this population, from the huge set of population, and try to pick up some that is good, what to say, starters, we call it as parents. And these parents, you can apply mutation and crossover. Mutation is like, on a particular gene, you replace, when you have 1 1, its muted gene could be 0 1 0 0. Okay, so you can replace some context by other, and we can say it is mutation. Crossover means two genes combined together. Okay, so you have 0 0 1 1, you have 1 1 1 1. Okay, you take this part from the first gene, you take the second part from the second gene, mix. It's a hybrid variety, hybrid tomatoes we used to see. Okay, nowadays everywhere it is hybrid only. That is what we call as crossover. By applying these two, we can end up with a lot of offsprings. Okay, the quality of parents matter a lot. You pick proper parents, apply this operation, it may end you with proper offspring. Okay, why am I telling it may end up with? Because there is no surety. It's all trial and error of how mutation and crossover is happening. How do we know whether the created offsprings are correct or not? It is through the survivor selection, which is nothing but the fitness function. Okay, you write a fitness function. You say, yeah, threshold, that is when the output holds above a threshold value, I can take it into the population, or else I will remove. Okay, so this is the genetically evolving algorithm in the human being, and the same is being applied here. So what is actually happening in the algorithm? So you'll have initial set of solutions. Okay, so you arrive at the solution by your own means, not a problem. So you have initial set of solutions, and from there you are going to select fittest individual who form the parent community. Okay, so solutions may be 100. When you Google for one IPython notebook for this, you will have 100 links. Okay, are you going to use 100 links? No. Okay, I'm going to pick up only 10 from that. That becomes the parent. So I will open 10 notebooks. Okay, pick up something from here, something from here, something from here, do mutation and crossover, create my own offspring. Okay, check whether my offspring is working or not. If it is working, I will load it to my GitHub. It becomes my new population, right? That's what is happening nowadays. Nothing wrong in it unless or until we understand and do it of your own. Okay, so that's what is happening. So you have to pick up the proper parents, do either of mutation or crossover, or both, depending on your interest. Okay, and then result or of mutation or crossover is what we call as the offspring. Okay, and then you check whether they are good enough to move on to the population. If it is so, move ahead, do it in an iterative way unless or until you get proper solution as the output. Okay. So neural network, what are the advantage? It doesn't need powerful computers to work with because it needs only multiplication operation, supports multiple inputs and multiple outputs. Yes, multi-class attribute can be evaluated using your neural networks. It needs a very large data set for learning properly. Okay, so learning properly, that's important. So when you want a perfect output, you need to have a very large data set. In contrast to that, genetic algorithm need powerful computers to work because it needs parallel computation. Okay, and it supports multiple inputs, but it can always produce only one output. So multi-valued class output we cannot get in genetic algorithm, and it doesn't need a very large data set because all that it does is the random pickup of population. Okay, so neural net has its own advantage, genetic algorithm has its own advantage. So by taking into consideration these two advantages, can't we go for any innovations with neural network and genetic algorithm? Yes, of course, people have done a lot. Now, you look at this. This is your overview, abstract view of the neural network. The inputs, can you change? It's not possible. Okay, can you change the output? No, because that is the computed output. So what can you change? You can have changes in the topology. What do you mean by topology? So here one hidden layer is there with 5 nodes. I may increase it to 2 hidden layers with 4 nodes each. Okay, or 3 hidden layers with 10 nodes each. That is topology, the structure of the neural network that you can change. Okay, and how to give the weights, okay, because all that is matters on the weights. How much weightage are you giving for a, if the weightage goes more appropriate for all the student community, no issues, you can move ahead. Okay, if the what to say, the weights are very low and which is more ahead of what is expected, number of iterations, that's the concept. So what can we do? Select proper words, weights. Okay, so that is one innovation that we can bring in. Then comes the inputs. Okay, so here there are 3 inputs, not a problem, but there are data sets having 100 features, 150 features. If you really see whether the 100 features are useful or 150 features are useful and all, it's not really like so. So can we go for feature selection? Okay, can we reduce the number of inputs, not the inputs? Keep in mind, we are not changing the input values, rather the number of inputs can be reduced using the feature selection. Okay, so these are the possible things that you can do where we can think of whether the genetic algorithm can be added up to this neural network structure. Okay, so with that, if you see the hyperparameters selection, what are the hyperparameters? This simple number of hidden layers is one hyperparameter. Okay, well, how many number of nodes you are going to use in a hidden layer is another hyperparameter. All that you can use genetic algorithm to set. Then you can go for topology evolution. So topology evolution we saw now, whether to have one hidden layer or multiple hidden layer, how do you evolve that topology? That matters. Learning to evolve with topologies. Then reduction in backpropagation. So because most of the time is getting wasted only in backpropagation, is there any possibility to reduce the time taken and the number of computations required for back propagation to correct the errors on your weights? Is what can be researched on this domain. So all these area we can apply genetic algorithm to improvise the quality of neural networks. Neural networks as such, we are not going to change anything on the functionality of neural network. Rather, over the neural network, we are going to add some more genetic algorithm functionalities to bring in some innovations. And whatever we have done till now, in the next 15 minutes, I can explain you of different case studies. Okay. So first, I need some quick answers on that. Please have a look at this. So this data set is about actually a real-time data set which we collected at our institute, and we have gone through a detailed study and a publication. So it is performance and emissions characteristics of a dual fuel engine. Dual fuel engine is one where along with petrol, some more biogas can also be fed. Two fuels will be fed at a particular time, and it will be mixed with the proper proportion due to so many reasons. Okay. So actually, in our laboratory, the engine was tested, okay, under these four input condition. Load, how much load? It varies from 5 to 20, okay, 5, 10, 15, 20 are the load variations. Then biogas flow rate, okay, along with petrol. This is on a diesel engine, so diesel plus biogas. Okay, so different flow rates from 2 to 20 are given and the readings are taken. Then methane fraction, how much proportion of methane are we going to add on the biogas? So that is from 15 to 100, 15 to 100 on a scale we have taken. And on what is the input temperature on which the biogas is fed to the engine for running. Okay, those are the input parameters. And actually there are a lot of different output parameters, but one important output is the emission characteristic. Okay, emission is calculated basically on carbon monoxide. So how much is the output that the machine is able to give on a that is the carbon monoxide, how much carbon monoxide is this the machine giving on different values. Okay, so why do we go for machine learning here? So they have taken the inputs, they have run almost 400 to 500 runs, and they have taken the readings, right? So now why do we go for machine learning first? So finding optimal value need exhaustive experimentation. See, when I cannot say that this is the value on which the machine is giving very low carbon monoxide, right? You have to run, and you have to do an exhaustive experimentation. Even if you run for 1000 to 1500 times, no, the next person will come and ask you, what is the 1501 output? Okay, so there will be a lot of wastage of biofuels, money and time, and human resource. With increase in range of input parameters, we are not able to arrive at an optimal result. And hence, in order to take advantage of this ICT techniques, we went for machine learning modeling. Okay. Now, can you tell me for this data set, what kind of machine learning model can we use? I have shown you the input. Input are all numbers, load, biogas, methane, and intake. The output is CO, which is also a number. Okay. So only one output you assume. Then what would be the appropriate machine learning algorithm we can use? Yes, anyone, please. Do you need to go for prediction or classification?
Classification 0 or 1?
Actually, the values of CO are not 0 and 1. It is 0 0.13, 12, 15, 11. Likewise, the numbers. It's in a range.
So prediction, maybe the prediction will be a right one.
Yeah, thank you, ma'am. Actually, the concept is to use prediction because the values lie in a range of something. Okay, so if you look at here, it is from 0.9 to 0.15, but in a real case, it is between 0 to 1. So we applied prediction, we arrive at the result. What is the result? We get to know. So you would have seen the regression formula, right? So it will be like y is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus bias. So what is this m1? It is all the slopes of each and every variable. Slope is nothing but the weights. Okay, weights that is computed. X1 is load, the second parameter, third, fourth. Okay, so now that you have the values, let's say you have 0.4 x1 plus 0.5 x2 plus 0.8 x3 plus 0.6 x4 plus 0.1. If this is the equation that we got from there, okay, by using that, what can we do? When I give new values of x1, x2, x3, x4, I can able to arrive at an output y. That's all. Okay, what else can I do? If somebody asks me what would be the possible carbon monoxide output or the emission for these values, I can able to tell. Is this enough? No, actually. Okay, so actually what information are we trying to give from the existing data set. That is more important rather than your machine learning model. Modeling is not enough. Rather, what is the expectation from the researcher here is, what is the optimized value of input in which the carbon monoxide is very minimal. Okay, so what is that I should do? I have to minimize, okay, CO, right? What is that? I need to know the minimal value of load biogas, or the value of load biogas, methane and temperature in which the carbon monoxide is very minimal. How do we measure? Is it possible to go for, see, actually we told you like load goes for 5 to 10, 20, 5, 10, 15, 20. The second goes for 2 to 20. Okay, 2, 4, 6 in terms of 2. The third parameter varies in range of, yeah, that is in 15 to 100, any values. Okay, and then fourth ranges from, I hope, 35 to 50, I hope. Okay, so can we go for an exhaustive find out of all these things? It's not possible. Okay, you know the solution. Solution is this. You have to find out the solution like this. What is expected is to get Y. What is Y? It is nothing but the CO, carbon monoxide output. You have to find the minimized CO, which is nothing but this equation, subject to some constraints. Okay, so that's where we end up with the usage of one optimization technique. So this is what we have done. This is ML modeling, which you have seen. Then what we did is we have fixed the range of input parameters. I have just explained to you. Finally, we have gone for optimizing the input parameters using Lagrangian optimization. Okay, so once this is done, we could able to see, get the result like this. X1, the load has to be 15. Okay, the X2, the biogas flow rate has to be 14. Then your methane fraction has to be given in 15% proportion. Then your temperature has to be 35 on this corresponding scale. This is the optimized solution in which you can able to get minimized CO. Okay, so this is the first example where the optimization has been used in your machine learning domain. Then coming to the software engineering of what people are talking about, since this course is also being run from software engineering domain, there are many areas in which we can apply. One is to go for subset selection. Subset selection in a sense like in a software industry, many change requests come from different places, right? So the change requests gets increased on a day-to-day basis, but when the industry is going to release its next version, for example, if Samsung is giving their next release on mobile, it's not the fact that all the customer requirements can be solved immediately. Okay, only a prioritized set will be taken and that will be taken to market. Now, how do you pick up which is more important? Okay, so for a customer, something is important. For a that is salesperson, something is important. For a high-end end user, something is important. How do you know? Okay, so for that we have gone for using genetic algorithm. Again, it is also on a machine learning perspective. Earlier, it was on a decision tree algorithm called electri. Later on, machine learning. Now, since the data set is growing very large, future we can go for deep learning. But how do we do? I'll just explain a very generic view. So initially we collect all the preferences from the customers. Okay, using social media analytics, we go for Facebook, Twitter. Then we send individual feedback form to the user. Okay, we may that is the client may conduct interviews, market surveys. Those are different ways in which your data can be collected. Then from there the data set is created. Okay, so why this becomes a different hectic phase is that every output will be on a different format. We have to consolidate. So once it is done, you have to normalize and then finally prepare the data by removing noisy data using data pre-processing technique. Once done so, now what are the constraints for the organization? We have to find out, because there are a lot of constraints. It's not only that the user requirement has to be given weightage. The development person may not be available. Okay, the financial constraint at this particular time period might be the factor. The time that is available for you to take into market, it is a factor. Okay, customer preference is the factor. So various constraints would be there for every organization that we need to find. And then who are going to set these constraints? Okay, or is it a public product? Is it going to be available for all the end user? All that we have to make. Okay, and then identify the methods of collecting this constraint. Okay, I have found out these are the constraints. How do I fill the data set for that constraint? Okay, once having done so, we went for the genetic algorithm. Actually, here it is memetic genetic algorithm, where I have used one extra local search. Okay, so generally it will be on a global basis. Here I have scrutinized it for local search, and hence it is called as memetic algorithm. Memetic genetic algorithm only we have used. So the population becomes the user preferences. Whatever I'm collecting on the Excel sheet becomes the population now. Okay. What is the fitness function? Here is the disagreement. Disagreement is like from the stakeholders, we have collected the constraints of what to be delivered and what is available and other stuff. We have made it in the way of an adjacency matrix. Okay, that becomes the fitness function. So we have calculated the fitness function based on the constraint matrix that is created from so many stakeholders. Okay, once that is done, whichever population is not adhering to the fitness, we are removing it. Rest of all, we are trying to perform mutation. Okay, and then we do the basis, finally rank the requirements based on the thresholds we have got. And this prioritized ranking becomes the input for the software industry. Actually, we have given it to some industries also. And this is in association with one PhD work of my friend. Actually, this is a very interesting problem as a professor. Students are in need of personalized course recommendation, right? So every student nowadays, most of the colleges are going for flexible credit system, wherein the student has the flexibility to choose their courses. So if it is so, we have gone for one adaptive genetic algorithm based model to identify what courses could act as a best for them based on their history. Okay, the history we have recorded, like what are the grades and what is the curriculum he has gone through. From the curriculum, we run a deep learning model to arrive at the area of interest. We have 10 broader domains like data structure, databases, that is data science, and then operating system. Likewise, 10 major models based on ACM recommendation we had. And that one, what we do know, we actually have trained the student. Deep learning based training was given to the students' grade sheet. And this, as said, that is the output from the students' output, like what kind of grading is he got for this. Okay, based on that, his interest was mapped. Okay, so that was given as the input. And we ran again a genetic algorithm based model using the adjacency. See here, the adjacency indicates the fact of prerequisites that he has completed, because it is very important. So a particular course, S15. See here, if you take, this is S15 and this is S2. Okay, when there is a value like 1, it means S2 is acting as a prerequisite for S15. So when the student has not studied S15, this should not be recommended, and hence this is the fitness function. Okay, as and when this number gets increased, let's say if S15 is acting as a prerequisite for 2 courses, you will get an increase in number. So that's how the fitness function is done. And finally, after this is first generation, we gave different courses. Then the entire population we gave, and finally we came to know what course will suit for the particular number of courses left out for a particular student as of now by the end of the generation. So every level we used to scrutinize based on the prerequisite and the results that he has got on the different other subjects. So that is one work. And it was too much talking about, and hence I can show you one video of what we have done. I hope that would be. Is this video, is it visible?
Your slide is visible.
Slide. Okay, so 1 minute. Yes, sir. Now,
Yes, ma'am. Yes, ma'am.
yeah, just have a look at this video. Finally, we'll discuss about it. So I hope you can better visualize and understand what is happening. Yesterday, Dr. Swagadam Das, I hope, has ended up with this topic, I guess. So it is about the neuro-evolution that is there existing. That will be going to be the talk for the next era. So what happens in this neuro-evolution? We'll be trying to combine neural networks with genetic algorithm. Okay, so any evolutionary techniques we can use. Here we have used genetic algorithm. Just I will explain what we did. So here the intention is to make the cars understand for a self-learning perspective. Okay, so for autonomous self-driving cars, we may want the cars to understand how to drive on the path that we have set. Okay, so it is created in Blender, and we used Unity for modeling this. So what happens is we used genetic algorithm to train the model to give a better output of how many cars can able to reach or travel for a very longer period of time. Okay, so initially what happens, every time we are creating a population of 100 cars. Okay, so initially 100 cars gets populated. So as and when it starts moving, you could see they are not able to steer. Okay, and it gets moved on. So the parameters that are taken here for consideration are only two. One is the acceleration in which the car is moving. Okay, and the second is the steering. Okay, steering, whether it is able to move towards the left or towards the right. Those are the only two parameters we took. But on a 360-degree angle later on, we can able to adapt to any number of things. Now, as the generation gets created, the fitness function, what is the fitness function here? The ability to travel for a long distance with acceleration and proper steering. Okay, if it is not hitting on either side, we say the car is able to travel. And as long as if it doesn't hit, we are able to maintain it them in the population. If it gets hit, that's all, we are throwing it out. Okay, so only from the cars that are able to travel for a few distance, we are creating the offspring. Okay, so that is the actual work that we did. Okay, you could see some cars who are able to travel for some distance. Okay, only those cars attributes we have stored onto our database, and those are the cars, or those are the attributes, that the acceleration parameters and the steering attributes at the back is trained for the next generation. Okay, So likewise, this system gets trained automatically for many generations. And finally, you can see, okay, here after 10 to 15 generations, you can see the cars are able to travel without any crash. Okay. So this is actually, this was done a very long back, and now we have gone to a level to identify obstacles also as of now. Okay, so how do we go for obstacle when there is a that is a divider on the midst of a road? Automatically the car can able to identify that there is an obstacle. So how? So there will be a 360-degree glider at the top of the car, which is able to actually sense all the obstacles that are behind. That's how self-driving autonomous cars are moving ahead. Okay, so likewise we also have, you could see here in orange colors. Okay, those are the parameters that we are trying to take from there. I hope it was there here. Yeah. So we are passing, you can pass on the race on all the directions and trying to find out whether it is hitting or not. The same way, the other obstacles can also be identified other than the blank surface using image processing technique. So once it is done, automatically the obstacles can be just skipped off on its pathway. So that is the benefit. So here, what is the necessity of using genetic algorithm? Why can't we go on the regular scale? Nowadays, if you look at nowadays, if you look at in most of the cases, people are using a kind of reinforcement learning, wherein the cars are being trained using the feedback given by the driver. Okay, if it happens, what will happen? The car will mostly get, that is, the self-driving cars will mostly get aligned to the quality of the driver. Okay, so however he is, if it is trained with the rash driver, automatically rash driving will be the concept of autonomous car. Okay, so it is getting optimized with the characteristics of so many drivers. But why can't that auto also to be automatic? That's where we thought, and we have brought in this genetic algorithm into consideration. So this is one, and I'll stop with one more. For topology evaluation, can you see the screen, sir? I don't think it is.
No, your video is there on.
Yeah, 1 minute, sir, I'll share. I have opened my browser. Is it visible? Browser?
This one. Flappybird.com.
Yeah. See, this is another one concept done by my student. So actually, here also we have used genetic evolution. You could see here, this is just a Flappy Bird trying to move in the pathway which it is able to do. Actually, we have a scoring parameter. When it is able to move this stop wall, no, automatically the score gets improved. Okay, so till 13 generations, you could see this is not able to evolve. I'll rerun it again. You could see the topology will not be formed. Okay, so this is the output I need. This is the input. You can have any kind of topology. Just it is to simulate the topology evaluation using that. When it is able to move to a particular limit, automatically the topology gets evolved. Okay, you can see after some generation, it will able to try learn itself moving across. When it goes, you can see the high score gets increased. Okay, meaning that one Flappy Bird can able to move, okay, ahead of one hurdle. Okay, now the score is 3. So 3 hurdles we are successfully able to move. When it gets increased, automatically we are trying to make that Flappy Bird as the base for creating the offsprings. Okay, so the characteristics of that Flappy Bird, what are the characteristics? It knows how much it needs to jump on a particular time. Okay, so accordingly this topology gets evolved. Okay, there is no much of relation between these two. This is to say how the generations gets evolved, okay, as and when we try to make the system learn by itself, okay. So this is also done with the help of genetic algorithm. So many applications we can do actually. There are a lot many which we can think of to come in. So let me move on to the presentation. So I'll just explain this concept of. Yeah, my presentation is visible now, sir.
Yes, ma'am. It
Yeah,
is.
thank you. So now, how do we do that topology evaluation, the evolution? That alone I'll explain. And then initially we start with some n number of population. So any number of small flappy birds we can start. In general, you take anything. Okay, so this is one kind of methodology how you can apply. See, you can Google. This is the best methodology. People will talk. Okay. So this methodology will tell you how you can apply a genetic algorithm to the neural network. What we are going to do here is, so in order to get the best output, normally we go for back propagation, right? You create weights, random weights, create n number of hidden layers, apply the weights and reach out the output. When your output gets reached, check whether it is proper or not. If not proper, go back through the back propagation and do all problems. Okay, rather we apply genetic algorithm here. What do? You initially create n number of neural networks. Okay, it's not one neural network, it's n number of neural networks. Assign random weights separately for n neural network. That is most important. As long as you have variation on your population, it is very important in all genetic algorithm. Even if we have created 100 cars, the characteristic of 100 cars with which it has to start, the acceleration and the steering parameter we have set on a differing scale. If you are not setting that, automatically everything will run on the same perspective and you won't get any fruitful output. Similar way here, when I'm saying 50 different neural network, 50 neural network we have to create with differing initial weights. Okay, so we run the neural network, try to arrive at the output. Okay, check the output now. I hope, yeah, here we have. So each score each and every network. How to score? Every neural network can be assessed for its performance through the accuracy. What is accuracy? If you have 100 output, 100 training data, identify how many are able to get predicted or classified properly. Okay, divide by total number, we call it as accuracy. So this classification accuracy is the scoring parameter for the neural network. If it is very low, you can remove it. If it is above a threshold, let's say we want 80% accuracy, if the neural networks are able to arrive till 70, you can take them into the next population, combine the weights, okay? So take the average and that becomes the new neural network, okay? So average, I say it is for a generic case. You can apply mutation and crossover on the weights to arrive at the next generation neural network. Okay, do that. Finally, you will end up with a one neural network which could give you the proper result. Okay, this is very simple way of applying genetic algorithm over a neural network. This is how you can arrive at the topology. Okay, topology of your final system gets evolved from lot many initial systems. Okay, so that is one way. And another way is you have to go for feature selection. You can use feature selection that we will see in the hands-on of how many feature selection, how features are getting selected. And the third way is you can go for finding how many number of hidden layers and how many number of what to say, the number of neurons in the hidden layer using this, that hyperparameters can be chosen using genetic algorithm. The same way we have to adopt. Okay, so the population is what we have to pick up. Population is what you have to find, properly find according to the domain. Fitness function is what we have to write correctly. Both are correct, then automatically it will work out. Okay. Finally, what are we trying to achieve? So initially we were in that era. So machine are somewhat ahead of us, not touching us. But finally now, this is going to be the future. So we are, I hope we are in line with the machines, and we should not let the machines to go a step ahead of us, which will ruin the entire community. That's the problem with GANs, I should say. But nevertheless, it should be used only for a proper cause. So learning is always a fun and it will never end. We will go for one hands-on, simple hands-on for 5 minutes and then I can wind up. Okay. So just I will open that screen. Sir, please tell me whether my browser is visible.
Only your PPT is visible. No?
Yeah, 1 minute, sir. I'm sharing. Visible, no, sir?
Yes, ma'am. Yes, ma'am.
Yeah. So no problematic or complex algorithm I'm telling you. It is very simple code which is available in internet itself. So this is from sklearn.dataset. Okay, there is a classification package. That is a data set for applying this classification. So we are creating using this make classification. So logistic model is what I'm going to use. Okay, so what I'm going to do here is the feature selection using genetic algorithm. Okay, so we have around 15 features, let's say, on this data set. I'm going to use 15 feature. From the 15 feature, by alternatively trying out which feature can give us the better output, we are going to say whether the weightage to these features. Okay, so weightage in the sense of whether we can have it or we can be removed on a later state. That is what we are going to do with this feature selection. I hope the concept is clear. You are given with a data set having 15 features. You have some random data followed by an output. We don't want to work on it. Just the concept is to identify how many number of features are enough to give a better output or better accuracy as the output. Okay. So the model that I'm going to try is a linear model. Any model you can try. And for feature selection using genetic algorithm, this installation has to be done. This package needs to be installed. So when you want to install some package of this kind, exclamatory pip install that feature selection. Okay, so this package, if you give, automatically it will install with the internet connection. It will install. Oh, sorry. It will install the package for you. I already have installed, so it will overwrite that. Okay, so once it is done, so we are importing feature selection and fitness function. Feature selection genetic algorithm and fitness function. Those are two built-in functionalities that are available. If you want to make in changes, you can define override that using a function over here. Now, what we do is the entire data set we are going to divide into input and output, X, Y. X is my input, Y is my output. Samples we are going to take is 100. The number of features we are going to have is 15. Okay. And the number of class labels that we want, categories of class label is 3. Particular make classification will create an random data set for you having this information. Just I'm printing this x dot shape. If we want, we can print x also to understand how the values look like. See, it's all random values for 15 different parameters. The shape, which is 100. Similarly, I want to print this y dot shape. Hundred comma. Yes, you can see here. Then we are fitting the linear classifier, not we are running a logistic regression.
Excuse me, ma'am. Your voice is breaking.
Solve feature selection model over this. See this model. Model, what will it do? Given a new input, it can tell you what is the output. Okay. So X is your input, Y is your output. Okay. Now, what is the objective function that we are writing is we need to have a better, that is a fitness function. Automatically, you can see here from generation 1 it starts, okay, and in the 53rd into, sorry, which generation it is stated to have this around 70% accuracy, and hence once it is reached, it stops. So what happens here, among the 15, whichever is having 1 states that those are the features that could be used on a better scale to reach a better accuracy. Other features we can remove. Okay, so instead of this make classification, if you pass on your data set, you install. Here, if you pass your own data set with X and Y, automatically it can tell you what are the features. This is one way of feature selection using genetic ways which we can think of. The same get our own requirements. See, if you want to over this function you want to write, you can write here. Fitness function class, okay. Want, okay, so what are all the features that you want to retain, okay, and then when you want to calculate the fitness function, actually this is the fitness function we have calculated, okay. So it is, if you want to do it on a different scale, this is logistic regression formula likewise. So if you want to do it on a different scale, you can do, okay. So here if you see, by altering the fitness function to whatever we want, we could able to achieve an accuracy of 92.5%. So this is for feature selection. What I have shown you on the car is for what to say, better that is self-driving or any functionality, hyperparameter selection we should say. The Flappy Bird what I have shown is for topology evaluation. Okay, so that's about how we can employ genetic algorithm on deep neural network. Just I will show some data sets when somebody was asking, and we can close with that. So, ma'am, there are a lot of data sets that are available. Actually, if you see, UCI repository is one major repository that is available to have varying data sets. Okay, you can see here the newest data set that gets loaded will be on the middle. Most popular data set that people have used will be on the right. Okay, so anything, if you open iris data set is the most popular data set that people use. Anything, if you open it, you can have data folder and the description about it. You can see this data folder. If you open, you can download the data that is available. Okay, sometimes it will be in the form of a data. Sometimes it will be in the form of CSV or Excel. If it is in the form of data, don't worry, you can just download, open with Excel, it will be with comma separated only. So you can just use separator, comma to make it into different cells. So that is UCI repository. So here any data set you can get. Similar to that, the next important one is Kaggle. Okay, so this Kaggle is actually a competitive learning environment where they will be posting a lot of competitions. Okay, so you need Google Gmail for logging into that. And here you could see there are a lot of competitions that will be running here. If you want to compete, you can compete by selecting any competition. The biggest advantage over here is when you go for selecting some competition, see, $100,000 competitions also are there. Okay, so many things are there. Suppose if you are opening here, and if you want to find out who else have contributed, see, these are 162 teams have contributed. It's an ongoing competition. When you want to look at what people have shared, you can go to the notebooks. Okay, the people see here, a lot of things are there. You can check how people have done their works, and it's not for copying, it's all for learning. Okay, so you can visualize the entire code will be there. You can start learning from here. The only thing is we should have patience to go step by step to do all these things. So this is another very large environment, and which you can actually make use of. Okay, so not only this, specific to your domain, you have a lot of let's say if you are in need of healthcare, if you are in need of an intrusion detection, you have CUP data set. Okay, similar to that, you have different data sets that are available everywhere, so that also we can use. Okay, so there are a lot many data sets. I hope I have answered this one. Yeah. So with that, I think I am done, and thanks for your patient listening. And I'm sure at least the takeaway would be 50% of what I want to give. So yeah, I'm free to give or free to discuss any kind of